we stopped on compiling our first program, the Hello World. Well, maybe not for everybody first, but first in this course. And we saw that it gets relatively easy. So now we can deep dive into the C++ and what we can do in C++ and how to do stuff. And we start with variables. So if, as you said, you kind of know Java, so you probably are very familiar with this part. There should be no relevations here. It's just like you have your type for, like, it's a strongly typed language, so you have a type for every variable, and every variable can have only one type, and it's defined with this type. So first you type some type, for instance, like an integer, and then you give a name of the variable. And the only difference, I guess, to Java here would be that the variables are not automatically initialized as a general rule. So try to always have some initialization for a variable, because it's very painful if you forget it. So if you have a habit of not initializing your variables, it can kind of strike you back. Because a variable integer, this one can have any value. Because you just say, well, it's going to be an integer, and it just takes some part of memory, and it interprets it as if it's an int. And usually it's a 0, but not always. And these bugs are hard to catch, so kind of learn to always initialize the variable to a value. It can be a dummy value, but just so that you know which value it has. But generally, it's as simple as that. You just define a variable of a specific type, and you're done. Let's talk about naming. Yeah, sure.
Yeah, and the second one.
Yeah.
The integer, but it's a Boolean.
That is true. That is a mistake. That should be a Boolean, or that should be a 0. I mean, it will compile, because, as I said, C++ allows you to do everything, but this is a mistake. Don't do it. So I will change it in the slides that you get on the eCampus. That's a good question. Yeah, there will be mistakes in this lecture. So I'm not, like, I'm a human. I do mistakes. If you spot anything sketchy, tell me. Like, I'm happy to change it. I already changed the PWD thing from yesterday, so I'm learning. Okay, naming. Naming is very, very, very important. There are, like, memes going around the internet that naming is the hardest thing in programming ever. And I think we should treat it that way. So we shouldn't be scared of it, but we should approach naming really seriously, because a good name can tell a story. So don't be afraid to use a long name. Like, don't use names like A, B, C, and so on, because you will come back to it and you will want to kick yourself in the face because you will not remember what they mean. And then you will have to read the whole code again to understand what did you mean there. And if you just name them correctly, you won't have that. You will just look at it, okay, well, that's clear. That's, I don't know, this variable contains the weather in Bonn, for instance. Good. Don't use negation in the name. So don't name your variables not something, or don't do like a Boolean variable, don't update value, because then you will have at some point to negate this value, and then in your brain you will have to do double negation and so on. And we are humans, we're thinking slowly, it's not really scaling well. Right, so in this lecture, I will always name variables in snake case. It's commonly known as snake case, and it's also what Google style suggests. It doesn't really matter how you name them or what concept you use. This will not be enforced in the course. I suggest you to use the same, but the only thing that I strongly suggest is to use a consistent naming scheme. If you have a preference for a naming scheme, use that, but just use the same one. So don't, because it can lead to problems. So if you start one variable with a small letter and another with a big letter, you can have a variable, I don't know, hello, and one will have a small letter in the start, the other will have a big letter in the start, and they will be different values, variables. And you will be confused because you will think that you updated one, that you updated both of them somehow because you thought it's one variable, but you updated only one, and it can cause annoying errors. So just stick to one scheme of naming. I suggest snake case, and just go with it. Again, so C++ is case sensitive, so this variable is different from this variable. And that's why I just always name them in small letters. Good. Yeah, so longer names, again, like a lot of people, like that's a very strong position somehow for many people, even for professional programmers. Some people are afraid of long names because they're hard to type and so on. That's why you need a good text editor. Like good text editor will suggest you all the names and you just need to press tab and it will auto-complete it. So use a good editor, it will solve the naming issue for you. Okay, now kind of back from this detour and back to the types, to the type system in C++. We'll start with the basic ones. And we're going to spice it up with the modern things too. So there is a bunch of basic types like Boolean, character, integer, short. You probably know most of them from Java. They're kind of the same. So Boolean, it just takes true or false. Integer takes any number from 0 to a huge number. I don't remember it from the top of my head. And then if you need a bigger one, it's a long. If you need a smaller one, it's a short. Generally in this course, I guess for you it's going to be until the OpenCV part, it's going to be enough to just use like the typical Boolean, integer, float, and so on. Also, there are floating point numbers, meaning they're fractions. It's a float and double. We will dig deeper into how they're represented in memory, but not now. For now, you just have to remember that they're just floating point types. Good. And the funny thing here is probably this auto. I think you haven't seen that one before, and unless you know something about C++, it's a new addition to C++ 11, and it kind of figures out what the type is. We're going to be using auto a lot in this course because it's very reliable. It does sometimes it will generate an error that is hard to catch, but it's rare. So I think the benefits definitely outweigh the dangers of it. And in this case, this thing will be evaluated to an integer, this thing will be evaluated to a float because we put an f in the end, and this will be a double because there is no f. So whatever you don't explicitly say it's a float, it will be a double. That's it. And if you're curious, if you really want to dig into more details, feel free to do it. There's a link, just like when you get the slides, just click on it and read on. But there is a lot of information there, so I would do it a bit later if I were you, but it's important to know that there is a CPP reference website where there is all the information about everything you want to know about C++. And you should use this website. It's a very good website. It's kind of, it's encouraged to be used by big whales in C++. So like Bjarne Stroustrup also tells you to use that. So don't be afraid of doing that. Okay, so there are so-called arithmetic types. These are anything that has plus, minus, multiply, division, and so on defined for them. And for now, we know that there are like character, integer, floating point. We can add them, multiply them, divide them, and so on. I wouldn't. So again, C++ is very permissive. You can probably use a weird operator on a weird type. So if you divide one character by another, what will it be? Like if you divide A by C, what is the result? I have no idea. Probably it's going to be 0 in this case, but it's hard to tell. So don't do something that doesn't make sense in the real world. Think about what you're doing. Don't just do stuff. It of course makes sense to multiply and divide other numbers like floating point numbers or integers and so on. And it works pretty much as you would expect. So if you put a plus between two numbers, it's going to be a plus, and so on. You know that from Java. Also, the comparisons work exactly the same. There is lesser, greater, lesser or equal, greater or equal, and just equals. Equals is double equal sign. Again, this is mostly for those people who haven't worked in Java. It's just the same. And every operator of the comparison operators, return a bool. So you can use it later in some, so you can assign it to a bool value, for instance. There are shorthand operators like plus equals is actually like, so A plus equals is A equals A plus 1, and the same goes for most of the other operators. The only thing that is very specific to C++ and the way it handles floating point numbers is they're imprecise. So there is always some imprecision. And if you have, say, if you say float x equals 2, it can actually be 1.9999999 and so on. And that's why try to avoid using equals for floating point numbers, because it might backfire. It might actually, you would expect the number is the same, but it's not the same. So use like a greater and so on with some epsilon around the number if you need that. Just, I think, important to note. Okay, there are some additional operations. So for Boolean, you can do or, and, or bitwise, or negation. So for instance, or is, I mean, it's just a typical Boolean magic, like the way it works all the time. So if you have a false and a true, it's going to be a false. If you have a false or a true, it's going to be a true, and so on. There are tables for that if you kind of need to brush that up. So for instance, like if I can be happy if I'm hungry, if I'm not hungry, like not hungry and warm, or I'm rich, for instance. Just a small example to catch your attention. All right, integer variables, they're a bit different. They are, so if you divide two integers, it will be an integer. It won't be a floating point number. It will not convert it automatically. If you want a floating point number, you have to add like a dot 0, for instance, after an integer. Otherwise, it's going to be an integer division. So 7 divided by 3 is going to be 2, because like 3 is within 7 only 2 times. And it kind of, for beginners, it causes a lot of mistakes. So when you divide one integer by another, always keep in mind that they are integers and they will stay integers. If you want a float, make sure you are actually giving it a float. The types will be converted to the biggest type. So if I put here 7.0, all the expression will be converted to double. Okay. There's also modular division for integers, which is exactly, I mean, kind of the opposite of the integer division. So 7 by 3 is 1 because that's all the things that are left. So it's the remainder of the operation. So it will be like the it's kind of 7 minus this 2 by 3, if you can think about it that way. If that's unclear, we can do more examples on that, but it kind of should click. And it's useful in a lot of cases, but it's not like very, very often used generally, at least from my perspective. Okay, then there are increment operations. The A++ and ++A, generally they are the same, unless you're doing this, which we'll come later to. What it does, it's a shortcut to writing A plus equals 1. And that's it. The same works for minus minus. There are no other operations that do the same thing. So I will be using this small guy over here that I stole from the book Code Complete 2 by Steve McConnell. It's actually a very good book and just about general programming and how to treat programming, how to think about programming. I think it's a good read for everybody, but it's a big book, so if you want to invest some time in it, definitely worth it, but not a must. Anyway, this picture is stolen from here and it will generally show you a bad example, so you shouldn't do the thing where this guy appears. And you definitely shouldn't do something like this because it's really hard to guess what it will evaluate to, because these operations, they have different order of when they happen. So for instance, this guy will first update B and then will return a value, and this one will first return a value and then update A, and it gets really confusing, and it's not really needed for modern programming. If you find a person who writes this code, punch them in the face. Don't work with them, and just explain them that they're wrong. Like, don't use this at all. Okay. Good. Now let's come to strings. So we can use strings to represent any array of characters, basically. So if I want to type hello world, that's my type. And they work pretty much, they are part of the standard in C++. There is a huge standard library, which we will talk about a lot in this course. They are part of this library, and they are, you can think about them for now as part of the language, even though they're part of a library, but they work pretty much like any other variable for now. And they work out of the box with input-output streams, so you can read into an int, or you can write into a string, sorry, or you can write from a string to the console. It works pretty much as you expect it to. Also, you can concatenate strings with a plus operator, so if you have like a hello plus world, it's going to be hello world together. And this is just a small example over here to make sure that everything runs. And the important part is you need to include string. We are kind of already familiar with these includes, and it's a built-in system type. So you have this kind of angular brackets over here, and usually C++ knows where to find it. After that, you can use this std string to hold like any variable of string type, which is encapsulated in those quotes here, and so on. The same with, so this type you can actually leave uninitialized, but I would still initialize it anyway, just for the sake of building a habit. And you can see that you can concatenate a bunch of them also with implicit strings and so on. So this will be converted to a string automatically and will be appended to this. And so this works pretty much out of the box. Good. Now, we can also have a collection of items. So it's not enough that we have just one number or one string. We want maybe arrays of those numbers. And there is it's actually a recent addition to C++, which was a long time missing. It's called std array. And basically what it does, it creates a fixed collection of items. If you have, like from the start of your program, you need a collection of 3 items, for instance, like 1, 2, and 3 in this example, you just create it from the start of the program, and it will never change. And you can go through it, you can use it anyway. But the important part to remember here is that you always define it with the size. So the size is given as one of those parameters. So before we saw like only a type here. Now it's array of floating point numbers, and the size of this array is 3. It's extremely efficient, so it's very, very, very fast. Like all the access is nearly 0 overhead. It's as if you would have just written in the code like float 1, float 2, float 3, and then would access them. It kind of like there is no overhead of using that. You can access items by index, and for those of you who like MATLAB, this is a real programming language. Indexing starts at 0, like there is no 1. And it goes up to size -1. So this is something you have to get used to, but again, if you have experience with Java, you're going to be fine. Right, you can have the size of the array like this, so you just ask it for a size. It's going to return how many elements there are, which is generally this 3. It's not very useful for arrays, but we're going to come later to where it is useful, because the same method is defined for most of the standard types, like even string or array, and the ones that we will see further. You can also, actually I have to check that. I'm not sure you can do this, but okay, let's for now skip that. But the important part is this. So if you want to have a first element or the last element, which is kind of a relatively, you need that relatively often. There are shortcuts for that. I mean, they're not really shortcuts because it actually becomes longer, but it's more readable. Again, so longer is better if it's more readable. And this is more readable because it kind of tells you that it will return you a front element or it will return you a back element without having to know what is the index that you're passing into it. Now, the more typical type that everybody is used to in C++ is a vector. It's kind of the main type of C++. Like everybody uses it. It's like there is no program in the world that doesn't use vector, I guess. And it's used exactly in the same way as array, but it doesn't have a fixed size. So it will grow and shrink upon adding elements to it. You can add elements at any point of time, and you can add as many elements as you want, as many as you have memory to hold, because the only limit on the size of this vector is how much memory your computer has. That's it. So it can go insanely big. To those who know some computer science, it's a dynamic table, and that means that when it starts with some size, and then you add elements to it. When it reaches some filling factor, so let's say it's filled by, say, 2/3 now, it will actually copy all elements into the new memory, so it will grow, like it will get bigger. And we will talk about it a little bit, but it's just important to keep in mind. But generally, you don't need to remember it every day where you're using it. So the main part is that the elements are accessed in the same way as in array. You can still use size. You can use clear to remove everything. There are other methods that you can also look up at CPP reference. This is a good page. Like, it has all the methods listed and with the parameters that you can pass to them. The difference to the array are these two vectors. It's pushback and in-place-back. So pushback is a classical method. Like, it has been since C++. So the standard C++ is 0.3 standard. C++, it was there a long time. It has been changed intrinsically in C++11, but it does the same thing. So you can just add a value to the back of the vector, and this is used a lot. I would suggest you to use in-place-back in C++11. So it's historically better known pushback because it was there since ages, but C++ has changed a bunch of things under the hood, and these two kind of do nearly the same thing. Generally, this will be more efficient, or at least as efficient as the pushback. So use that. If you have a preference of using pushback, use pushback. Not really important, but I felt it's important to note that. So in case you see in-place-back, don't get scared. It's kind of the same. Okay, and again, I want to stress it. It's a very common type, so people use it a lot, and you should use it a lot. Like, it's fast and flexible. It will work for you. Okay, now I've talked a bit about resizing, and there is one important thing that you have to remember if you do a lot of pushbacks in a row. So if you do a lot of them, it will be resized many times. So if you have like a vector, an empty vector, you will add like one element to it, it will resize itself. You will add another 3, it will resize itself again. You will add another 10, it will resize itself again, and so on. And every resize costs you time, because every resize means that the processor has to copy over all the data to a new vector and so on. And you want to generally avoid that, because copying memory is the expensive thing. Like, this is what costs you time. So if you really want to make something fast and you know approximately the size, like how many elements will you be adding to a vector, use reserve. Reserve ensures that your vector will be able to hold as many elements as you need. It doesn't change the size of the vector. It just tells that if you do this many pushbacks, it will not reallocate memory. That's it. So it doesn't cost you anything to add one line. So this one line, if you don't do it, it will still work. So the whole code works even without that line, but it will be slower. Also, n doesn't have to be precise, it can be approximate. So if you know it's going to be approximate 100 elements, it's already really good, because you know at least there's going to be like kind of 100 elements, so it will not resize many times. Maybe it will resize one time. Good. So let's probably do like an example of this thing. Maybe you will have some questions to it. So we have a vector, and you can initialize any vector of, so let's say an integer, and I mean the names will be really bad here because live coding is not about naming really. So this will create a vector of 2 elements, for example. Now if I want to, so let's say I want to print something, so I need the stream and back front, back. All right. So now I have this thing, and I can build it probably. No. This is a really old code of mine somewhere. Does it work? Yeah, so if I don't provide any name, it will be a out. I can also provide a name here. Okay. So now it's 1 and 2. As expected, this is how it should be. Now, if I want to add something else to it, I can just push back like a 3, and it's gonna, whoops, that was not intended. I can build it again, and now it's gonna be 1, 3 because the last element is 3. As I told you, the compiler is generally smart, so if you try to add like a double instead, it should fail. It doesn't, because that's what I'm saying why C++ is kind of dangerous. So it will do stuff that you don't expect it to do. So now it converted automatically the 3.0 to 3, which is an integer. And in this time, it kind of worked, so it was 3. But if it would be like 2.99999, there is a chance that it would be converted to a 2. And beware. So if you put it 3.1 here, it actually, come on, it should compile. Ah, but there is a warning at least. Right. So there is an important flag. It's you can remember it as wall, but it's actually -w all, and it's a flag that tells show us all the warnings. And now we have yeah, right, this is a different error. Yeah, we're going to come to that later. I don't know why it doesn't link. Okay, anyway, there is a warning for this part because it knows that it's a double, but it tries to convert it to an integer. But generally, so at least like if we type here like a string which cannot be converted to a string, then this should, yeah. So now it gives us a lot of errors, and this is how the errors look like when the compiler doesn't know how to do something. So basically it tells you that there is no matching function for call to pushback, and reading errors in C++ is a skill. Like you will get better in it with time, because sometimes it's not, like it would be really nice if it could tell me that hey, you shouldn't use string there, just use integer there. But it doesn't tell you that, it tells you that there is no such function that it can find to use an integer in. And this is why it says that there is no matching function. And what you need to know is that at this point, so okay, so it says invalid conversion from const character, which is kind of an internal representation of a string, to an integer. There is a lot of boilerplate text over here, and again, it takes some time to get used to, but I believe you will. So in this point, you have to, really important thing, read errors from the top. Don't start reading errors from the bottom, because the bottom errors are garbage. So it will still try, like when the compiler encounters the first error, it will still try to do other things. And these other things will be influenced by the mistakes it has done before. So the first error is the one that you want to solve. Don't try to solve all the errors all the time. go to the topmost error, try to find out its cause, solve it, recompile. That's generally the way you're gonna save yourself some trouble. So in this case, even though it's a bit blotted, it's kind of clear that the problem is in the pushback function, and that if you read a bit further, it will actually tell you that it cannot convert from an integer to some other type. Good. Anything else you want me to try out? Like anything else that is not clear with this? Because I feel like this part is important. Yeah.
How can you add a value like between 1 and 2?
So there is an insert function in a vector, but generally you don't really want to use it because it's not really efficient. So the pushback operations, so generally you should think about a vector as something that grows like from the back and shrinks from the back. In my day-to-day use, I rarely have to shrink a vector. So I usually just, it just grows, and then when you have enough elements, you work with them, and then you discard all of them. So it's kind of like an array that can, I treat it the way that it's an array that can grow, I can use it afterwards, and then I can discard it. There are all the possible methods to remove any element in the middle. There are methods to add something to the middle. So for instance, if I want to add something, I can probably use insert here. It's going to be a bit, I'm not sure. Let's try that. This probably won't compile because it needs, yeah. So it needs some heavy, let's put it that way. Under the hood, there is a bunch of things that the vector does that are pretty complex. And I don't want to go into them now, but we will discuss them a bit later. So you need, there is a thing that we won't really go deep into now, but it's called an iterator. An iterator just iterates over a vector. And this iterator can be passed here. So anyway, for now, treat vector as a container that grows, and then you take it, and then you discard everything from it, okay? Because I think this is the way people usually use it, mostly, and it will also kind of protect you from a lot of pain for now. But it's a good question anyway, yeah. It kind of makes sense that you should be able to insert and remove stuff from a vector. Okay, anything else? Yeah?
You haven't resized the vector yet.
Yeah, I don't need to resize the vector because it has, so in this situation, I don't add a lot of elements to it, and every pushback resizes the vector. Actually, we can visualize that. So if we type here like size, okay, so size is 2 before I add something to it, and did I remove? Yeah, I removed the adding. So place back 3. Sure. Okay, so now the size is 2 and 3 because I added an element in line 8 over there. So whenever you do a pushback or in placeback, it actually resizes the vector, so it adds size to this vector. Right. If I would have to add a lot of elements with a pushback, I would use reserve, because reserve kind of tells that even though the size of the vector doesn't change, the memory allocated for all the elements is still there. So if I would add many of the elements with pushback, I would actually use reserve. But if I add like a couple, it's usually fine. So it's kind of an optimization technique. If you have like a lot of elements to add to a vector, you should use reserve. Otherwise, you shouldn't bother. You should just use pushback and so on. It works just like that out of the box. That was kind of clear, or?
Yes.
Okay.
But how to add the 3 to the vector?
How to what?
Add it.
Add?
Hinzufügen.
Yeah, so like this thing actually adds 3 to the vector. So now it's the
2 is deleted.
No, it's not deleted. It's just not the. I'm not printing out all of the elements of the vector here. It's just I'm just printing. Sorry if that was confusing. I'm just printing the first and the last one because for now we don't know how to go over all elements in the vector. We will get to that in this. I think in this lecture. Yeah, in this lecture. But for now, it's just the first and the last element. I'm just saying that we add something to it. The 2 is still there. Like the size of the vector is 3 in this situation. Sorry if that was confusing. Okay. More questions? Okay. So again, like I encourage you to play with it. Just like open any console, write a small main function, try things out, look what they do, look what mistakes you get. If you can't read a mistake, try to like search for it, how to read it. If you can't do it, ask me. Reading errors will take some time, but that's the way it is in C++. Okay, an important concept, I think the most important concept of the memory, like whenever you think about C++, you have to think about this. Like this is why C++ is so efficient and why it's used all over the place. It's because of the scopes. So every variable lives in a scope, and a scope is everything that is defined between these brackets. So whenever you see those 2 brackets, unless it's some definition, it's a scope. So for instance, this is the main scope. Like it starts from main, goes up to here, and then this is some other scope. You can create as many scopes as you want. Every function like main creates a scope. We will talk about it also later. And there is also one big global scope. So there is like a global scope, there is a scope of the main function, and then there are any other scopes that you define there. Now, why is scope important? You can think about a variable belonging to the scope where it is defined. Because if you create a variable in the scope, it will be deleted when the scope ends. So in this case, I think it's easier to show it again in example. So we're gonna, let's leave our vector, or like let's not go for vector, let's just go for int, some number. Let's set it to 1. And let's create a small scope, and here like int blah 2, and then let's try to say some number is blah, right? So if we try to build this thing, it will complain because, yeah, I forgot the equals, of course. Okay. So now it will complain that, so this is kind of a very typical error that you will see. Something is not defined in this scope. So scope, now you know what it is. It's just anything between those curly brackets. And it says that, also I didn't say that, but it shows you the line where it happens. So it tells us that it's in a line 9 and in column 17, the error that happens. So if we go back to the code, we go to line 9, and we see that this blah is not there. So it's not defined there because it was created in this scope and removed within this scope. Like it's a very stupid program to write because it doesn't do anything, but it kind of illustrates the purpose, because whatever you create in a scope will be removed by the end of this scope. The cool part about it is that this basically defines how C++ manages memory. So that's why you don't need any garbage collection like in Java, because everything removes automatically when it reaches the end of the scope. Right. So I think if you kind of like go out of this lecture today and just remember that there are scopes and variables belong to scopes and die in the end of their scope where they were defined, that's enough. That's really good. Like, that's very important in C++. I think it's like the thing that defines C++, at least from my perspective. Okay. Let's talk about constants. So for now, all the variables could have been changed. So for example, if I type this some number, it will get changed. So it was 1, now it's 2, that's easy. But if I want to make sure that this number never changes, I will type const here, and now I should get an error. Yeah, so now there is an error, that assignment of read-only variable, and this is actually what I want, because if I want to set something to not change, I want to make sure that it never actually changes, because if it changes and I'm not expecting it, then it can backfire. I can expect it to have some value in my code and it doesn't have this value anymore, so I want the compiler to protect me from my own mistakes. So if I change it by mistake, I want the compiler to tell me, hey, you shouldn't really do it. So const can be used for any type. So it can be const string, it can be const int, const float, anything. Yeah, it becomes the type, part of the type of the variable. So if you have a const integer, the type of this variable is not integer, it's now const integer. It's important to remember that it becomes a part of the type. And you can't just get rid of it easily. There are ways, but you shouldn't use them really. And so the Google style suggests to have a specific name for constants that you define, especially the ones that live through a bigger part of the program, and it should be used. So they suggest to use camel case here. So camel case, if you wonder why it's camel case, it's because the camel has 2 humps, and that's like the camel case, 2 humps there. So and it starts with a small letter K. So I would in this example, it would be not some number, but it would be something like this. The cool part about it is that a lot of editors support this naming scheme, and they will actually highlight the constants in a different color, like here, which is really nice, because if you use it somewhere, you can easily see that it's a constant while coding, which is nice. Okay. Yeah, and I think it's very important to treat constant as a must. So if something doesn't change, use a const for it, because it's kind of part of defensive programming. Defensive programming means check everything that you have as input, that it's correct, and do not allow yourself to make mistakes. If you don't expect something to change, set it to const, because then if you actually try to change it, it will complain. And I think this is really good. Okay, you can also use references to variables, and this is kind of this is one of the, so we go to the C++, the kind of the fun part of C++, where things can get non-linear. So for now, everything was linear. Like for now, we defined a variable. If we change it in the scope, it changes, and so on. Like it was very simple. But with references, we get kind of this layer of indirection, and we're going to talk about it right now. So first, the syntax. Whenever you add this ampersand sign to after the type, before the variable, it's going to be a reference to the to a specific variable, and it also is part of the type. So now the type is not float; it's float reference, and it is important to think about reference as just an alias to your variable. So if I say now my ref variable is original variable, it actually means that they're completely identical. So if I change one of them, the other changes also. Yes, so let's do examples, I guess. Okay, I will not remove cout because they're annoying to type. So let's have some, whatever, integers, integer, num, and let's have a reference, num ref. So also I cannot send, I think I cannot set it to just a number, it will complain. Yeah, so this is kind of, again, the error will not be the most readable at first. You will get used to it and then you will know exactly what happens. But at first you have to not be scared of this word R value. R value means that everything that can stand on the right side of assignment operator is an R value. That's it. That's all you need to know at this point. And at this point, R value is 2 in our case. So, and it cannot be an R value, and that's why it complains. We will go deep into that, but when we talk about all the memory stuff, it's going to be later in the course. For now, you have to remember that you cannot assign a number to a reference, because a reference can only be a reference to a variable. So we can set num here. And now our numref actually is a reference to the num. And if we, so we can output both of them. Numref. Okay. And let's copy this thing here. So now what we do here is we define a reference, we output the number and its reference, we change the number, and then we see what goes on right there. And you can see that they both change. So they're completely the same. Like, yeah.
Why do we do that?
It's going to come. Like I think it's important to understand this concept from the start, because it's going to be used like a lot, especially when we go to like using functions and so on. I think it's even in the bottom of the slide. We will reach that part. But the important part here is that references are exactly the same as the variable that they reference to. So if you change the reference, it actually changes the variable. Now let's go back to also if I change. Let's do another small example here. So if I can do this, I can actually assign a value to a reference, and it will work just the same. So it actually changes both the variable and the reference, again, because they're the same thing. So why they're used is generally for performance gains. So there are two reasons, and one of them, the big reason, is performance gains. So if I have a huge string, also string can be as big as, or like a vector that is, I don't know, 1 gigabyte of my memory. And I want to pass it somewhere, like I want to have 2 variables that would hold it. Then I would need to usually copy it, but I don't want to usually copy it because copying is expensive. Copying means that the processor will go into my memory and will copy it bit by bit, and it takes a lot of time, especially for gigabyte of data. So if I use a reference is cheap. Like a reference is, the memory will stay the same. So it points to the same part of memory, and gives you a way to reference one variable from different parts of your code. For now, again, we are only talking about one function main, so it's not very useful, but it will become useful from like next lecture on, I guess. Or even, yeah, I think when we go to for loops and so on, it's going to be useful there. Right. The problem with it is I don't always want my reference to be changed. Like I don't want to give somebody access to my memory. So if I'm a variable, I don't really like somebody having a reference to me because somebody can just change me from anywhere in the world and I will not even know about it. So this kind of brings us a bit closer to the concept of ownership and like whatever. If I'm a variable, like if there is a variable, it should own like its memory because when it goes out of scope, it should be removed. Now, if it has other references, somebody else can change it, and it's not really clear in the code. So it's important to use const references when you just want to pass something that you're not intended to change. And it works just the same. So const works, as I said, with any types. Also, it works with types that are references. So you can add a const to a reference, and you will have all the benefits of the references, so it will be really fast, but you will not be able to change it. So for example, let's do here, instead of int, let's do a const reference. And so it will actually now complain because, and the error message is also really nice. So it will tell that we cannot assign a value to a read-only reference. And this is actually true. So we have a const reference over here, and then we try to assign a value to it. But if we don't do it, then everything else works just, come on, it's just the same. So if we change the variable, such a small thing does so much noise. If you assign like if you change the variable value, the value of the const ref will also change because it still points to the same value, even though it's a constant reference. All right. Good. So now we go to the control structures. So for now, this is all you need to know about how to create variables. We can try to do something with them. And the simplest thing that we can do with them is to branch our execution based on some statements. So for instance, again, you probably have seen it in Java a lot. There is an if statement, and you can put, so this statement can be any Boolean statement. It can be a variable, it can be an operation, it can be anything that gets evaluated to bool. There is also else, so you can have an else if and so on, and you can have just an else as a ending case. And also these can be ignored, so you don't need them. If you just need an if, it's enough. Like you can just use if. So this will conditionally execute your code. So as you can guess, if the statement is true, then this will be executed. If it's not true, it will evaluate this statement, and then if it's true, it will execute this statement. And if none of them is true, then it will just go to the else case. I think it's fairly simple. Good. Now, switch is a bit different. You give a statement just like into if, and this statement, so the difference here is that the statement does not have to evaluate to bool. It has to evaluate to any, integer type, or a thing that looks like an integer. So, and then you can have a bunch of cases for it. So in case you want to have many like if, else statements, consider to use switch instead. So for example, it can be like switch some number. So if you give, okay, let's probably go for example again. Switch. So if I have some statement here, it can be let's put num here, and case 1 we print hello, and case 2 we will print world, for example. So in this case it will print, yeah, and also let's do a default. Okay. So if we compile this now and we run it, it will print hello because the num is 1. If we change the number to 2, we can compile it, we can run it, it will print world as expected, and if it's going to be any other number than these, it will go to the default case and it will print the default case. So that's fairly simple. The only kind of pitfall here that you might fall into is if you forget this break. So there was a break here. If we remove it, it's going to be sometimes you need it, like sometimes you need to remove it, but the idea is that now if we go into case 1, it will not stop here, it will actually continue executing case 2. So let's see what happens now if we set the number to 1. Where am I? I'm lost. Yeah. So now it prints hello world because it doesn't stop after the first case. It actually continues to the next one. So this can kind of bite you if you forget to put this break. So remember, there has to be a break after every case. But that is all there is to it. So the important part is it has to be evaluated to a constant. So these have to be all constants. If it's not a constant, you cannot use it in the case. But that's everything you need to know. Is that clear?
Can I have a Boolean statement in the case?
Yeah, you can, but you should. If you have a Boolean statement, it's usually easier to write an if. So if I let's say it's going to be a bool and it's going to be a true, and it's going to be a true and it's going to be a false. Let's also add break, and we don't need a default because now we cover everything. Yeah, there is even a warning for that. So you see that it shows a warning. It's not an error. It's still compiled.
That was my question. The question was, can I use something like is smaller than 1?
Here?
No, case.
In case. No, it has to be a constant expression. So you can't do that here. But you can use an if for that, like again. So this is usually used for if you have a set of options and you have like an enumeration of those sets. This is where this is used. If you have just one thing that can go one way or another or a third way, you should use if. So I think we're going to have more examples. So at first, it doesn't really matter which one you use. Use the one that you feel is more appropriate for the task. It's kind of like the experience, like you have to gain some experience to know when it's more useful, when it's less useful. For now, just use it whenever you want, and you will get the feeling of when it's more useful and when it's less useful. Good. Right. Now we can actually talk about loops, and this is where we're gonna probably also start understanding why we needed references and so on. So there is a simple loop, while loop. Again, just as in Java, you have some statement, and the statement can be any Boolean statement, and it basically runs until the statement changes. So an example would be that there is some condition which is initially true, then we go into the while loop, and then this condition is getting changed by something. For now it's not important, but let's say it's just magic. So some magical way that changes this thing eventually to be false. The moment it's false, by the end of this scope, so what it does, it kind of like goes through the scope over and over and over. And so this condition, say at first it's true, it goes to the end of the scope, it evaluates the condition, it goes in and so on, and then it reaches the point when it reaches the end of the scope, the condition is false, it evaluates the condition one last time, says, okay, well it's false, so I will not go into here, and it will go wherever it needs to go afterwards. Okay? It's usually used when you don't have an exact number of iterations that you need to do. So you can do it many times, but you don't know exactly how many because it depends on some magic. And then you use while for that. The problem with while is that it can go into an infinite loop. So if you underestimated or overestimated your magic and your magic doesn't actually change the value ever to false, then this will loop forever. It's not very pleasant because it takes like your whole CPU for just looping through it and doing it over and over and over again, and your program hangs. So so use it only if you don't know exactly the number of iterations. Otherwise, use for. So a for loop is again a thing that you know from Java. It's all very similar because, of course, I mean Java was inspired a lot by C and probably C++ too. So there is an initial condition, there is an end condition, and there is an increment. An initial condition is you set some variable to a value. You can also define variables there. So for instance, like this, like you can have an integer e, like I defined here, and this integer will live only within this scope. So it's going to be only available in the for loop and not outside. Then you have a condition. You want to loop until I is less than, say, some count, for example. And you want to increment I. So generally, I suggest to use the prefix notation for increment here. It's a little bit faster because of some internal reasons that I won't go deep into. Just remember that use the prefix. You can also use a postfix. It was like so I++. It works just the same, but I suggest to use this because usually it's a bit faster, unless the compiler anyway optimized that. Right, and then this thing will happen exactly count times because we increment always by 1, and we start at 0 and we reach this thing. So whenever I is equal to count, this statement will be false and it will not go into the for loop. And this is where we end. So it's a bit less flexible than while because now we need to know how many iterations we have to do, but it's less error prone. So it's harder to make a mistake here because when we define rigidly how many iterations we do, and generally it's not possible to have an infinite loop if you write it that way. You can still write a for loop in different notation and then you will have your infinite loop if you really want to. There are ways to do it, but again, we're not talking about all C++. Use it like this, and this is the way to have a controlled number of iterations. Also, I wanted to talk a little bit about this variable. So if I have a for loop, so say I want to const int so let's say I have this thing over here. Right, so now I is defined within this for loop. So if I try to use I here, I will get an error. So it says that I is not declared in the scope because I was declared in the for loop. If I run this thing, it does what is expected. So it prints 0, 1, 2, 3 till 9 and so on. what I also can do, I wouldn't recommend to do it, but it's possible to do it, and sometimes it's useful, is if I have this I used somewhere else, I can just use the same I here. So my initial condition will be, so let's put it to 10, for example. It will still be able to use the same I over there. Okay? It's just so that you're not confused if you see such a syntax. Sometimes it's useful to use it, but generally prefer to declare a variable within the for loop statement. Also, it can be like I can jump. I don't have to do like a I++. I can do the I plus equals 2, for instance, and then I will have so the jump will be 2, and there's going to be less iterations. So you can go arbitrarily wild with that if you want to. Yeah, there's really not much to it anymore. Questions to that? All clear? Okay. The new thing in C++ 11 is the range for loop. Now, the range for loop is a nice thing because it shows intent. Like it shows what you want to do instead of showing how you're doing it. So for the old way to navigate the container would be, so if I have a vector of integers 1, 2, and I would go to, I forgot the name. So if I would go to vec size and I would increment I, and I would print just the an element of this vector. Let's maybe go for something like float so that it's a bit different. Okay, so it shows us 2 values that we have there. But the problem is that now there is a lot of boilerplate code that we didn't want to write it. C++ made us write it, and I don't really want to declare a counter. I don't really want to increment it on every iteration because it's not what I want. I want to go over all values in my vector. So in C++ 11 you can do it much easier. You can do it like this. So in this case, you can just use float number from vector. And this is going to be just the same. And this number will be the float that you read. And from my perspective, it's much more readable, and it shows what you actually want to do. So you want to go over all elements in the vector, and this shows it. So you say for number in vector, basically. And if we build this thing, it shows exactly the same results. Now if we go to, so let's say it's not a float. Let's say it's std string. We need string for that. And these have to be our beloved hello world. Okay, good. So now it's not a num anymore. So it will also check the types and so on. But what we can do is we can also use const auto reference. So auto will find out that we actually want a string, and in this case it will actually be a string, but it's going to be a constant reference to a string. Ignore the way it represents a string. It's just a string. So everything that has a word string in it is a string. Right. So and now we can compile this thing again, and of course it still works. So this is where the references become useful for the first time, because strings can be arbitrarily big. They can be huge numbers. Not numbers, they can be huge in length, for instance. They can be like easily like 100 megabyte string for, say, like some people use long arithmetic where the numbers don't fit into any type anymore, but you still need to do operations on them, and they usually use strings for that. So they have like a string which is, I don't know, like 1,000,000 character long, and they have to sum two of those strings. So that's what they use them for. And this string can take like hundreds of megabytes. So if we would want to copy it, it would take insane amount of time. We don't want to copy it, that's why we use the const reference here. So in this case, num will not actually be a copy of the string, it will be just a reference to that string. The string will still be lying happily in the vector. All right? Also, if we drop the const over here, we can also change something. We can change this number, and it's going to be changing the thing in the vector. I would avoid doing that usually, because it kind of makes it less clear of what is in intent, but we're going to talk about it more when we get to functions, I guess. So that is clear? The syntax is clear, the auto. Okay. Right, so generally if you don't have a weird pattern of jumping over the elements in the vector, use a range for loop. If you just want to iterate over all values in the container, use the range for loop. You can even use the same thing. So this container can be a string, for instance. Then you will actually iterate over all characters of that string. So if we do here vec front, and now it's going to be whatever, some character. It actually prints the hello letter by letter, because it's still a container. We can still iterate over the same container in exactly the same way. So now here, this is just one string, the hello string. All right? So, and this makes it really versatile. So this syntax really does what you expect it to do, and that's why people like it nowadays. So try to use it unless you need to jump over multiple values, or say iterate over two vectors simultaneously. Then you probably need a counter anyway. Right, you can exit any loop, and basically any while loop, any for loop you can exit, or you can skip an iteration of it. So let's say there is I use a lot of magic in this talk because we don't know what functions are yet, but we're going to replace magic with functions on the next lecture. But for now, let's say this magically I gets updated by somebody that we don't know, and it can be either divisible by 2 or not. And divisible by 2 means that the remainder of the modulo operation will be 0, right? So we either, like, we want to stop our while loop at the first number that is not divisible by 2, for instance. I don't know why we do it, but let's say we want to do it. So in this case, we check if the I is divisible by 2, and if yes, we output it. And if it's not, then we want to break. So we don't want to do this loop anymore, because this loop would go forever. You can do the while true. This is the endless loop. It's actually quite useful. I think most of the programs that you've been using in your life have at least one of those loops running, because it usually, so if you have any like graphical user interface, it needs to wait for your actions, and it always kind of like tries to like, hey, was there an action? Was there an action now? Maybe now. What about now? Did the user do anything? So that's why they use this while true loop. It's useful. Don't be afraid of it, but you have to understand why you're using it. So in this case, it will stop the loop whenever you reach the break statement. Do I have? I don't have it. So also the continuous statement just skips one iteration. So if I would want to only do whatever is in the loop, I can't think of a good example now. But let's say there is something in the loop that I want to skip if something happens. I just type continue and I don't go into there. I think we can do a small example here. Let's go back to using an integer vector because it's easier. 1, 2, 3, 4. Okay, so let's also int num. Right, so this thing will output all the numbers, but I don't want all the numbers. I want if num is divisible by 2, for example, then continue. Okay, so the idea here is that it's not very useful in this example, again, because I have to make simple examples because they have to fit on the slide and so on. But generally this part can be, so the part after the if can be arbitrarily long. It can be like a lot of things that you do. Like it's not only outputting something, but it can be some heavyweight processing, right? And you want to avoid doing that when your condition is not met. So you check your condition first, and if it's not met, you say, okay, skip this iteration, whatever, like I don't care about this iteration. So what it will do is, it will, of course, skip 2 and 4 in this case. So whenever we reach the 2, it evaluates to, so it evaluates, this evaluates to 0, and then we continue so we don't print stuff. It is useful if you have an iteration, like iterations of the loop that do a lot of stuff, but you don't want to process all the elements, but say some part of them under some condition. It can be any arbitrary condition in this case. So this is how you can use the continue. Okay, this is actually it for the control structures at this point. If there is any question to like if, switch, for, while, ask them now, because we're moving on from here. Okay, good. At least that's clear, I hope. Git. We're going to be using version control system. This is like the thing that everybody, all the programmers either use or should use. I don't know any big company that doesn't use a version of a version control system. We're going to be using Git. It's kind of the industry standard. At any job interview, you kind of have to know what Git is. What it does is, so first of all, it's free. A lot of things in Linux are free, which is nice. It's a distributed version control system. It means that you can have a history of your changes of your code on your machine, on somebody else's machine. Then you can work with many people, and they all have their own versions, and they will all be merged and synchronized onto one server, or many servers if you want to. And the synchronization here is the key. So you can work with many people simultaneously on the same code base, and Git will generally figure out how to merge the changes that you do to two files. And the important part is everything is recorded. So you will never have a situation where you change something and then in a month you find out that it was a bad decision, and now you don't really know how to return to that version because it was somewhere saved on some hard drive and you lost the hard drive and so on. Now it's all recorded on the server. You can just say, hey, okay, this is not working for me. So that was a version like 2 months ago, and I can actually just check that out. So you just go to the server, you pick the version that you like, you check it out, and it's there. And it's also saved in a way that it doesn't take all of your space. So it's a very nice system to use, and we're going to be using it a lot. As I told you, so the local files on your computer are synchronized with remote files on the server. These two words are important here. So local is whatever is in your machine, remote is whatever is on the server. We have a GitLab server in the basement of that building, and even two, I think. So you will be using that. I don't know, do you guys already have an access to our GitLab server or not? I'm always confused about how this is handled at the faculty. So who knows about the server and who has access to it? Okay, so definitely not everybody. Okay, I will figure out what's the procedure of getting accounts there, because it doesn't depend really on me, and we'll put it on eCampus. By the way, eCampus is live 5 minutes before the lecture. There's nothing there because it was 5 minutes before the lecture, but at least it's now live, so I can start putting stuff up there. And it's also good for you because you will get the homework. Like, otherwise, there would be no way to give you homework, but you're lucky. Right, so the GitLab server is situated on this link. So it's GitLab igg-unibonn.de. And this is the way you will submit your homework. So anything that is not in Git doesn't count. I will explain to you a typical workflow, and I'm always there for you in case something doesn't work. Again, as with all the tools that do complex stuff, in a simple way, something might go wrong. If something goes wrong, as always, try to figure it out. If it doesn't work, either write me an email, come to my office, ask me, like, I'm there for you, but it should generally work. So the idea is that you have repositories. All the code is within some repository. The repository lives on the server. If you want to check out a remote repository onto your local machine, you do a clone, because you want to clone the state of that repository onto your machine. You do it with git clone command, and you give it a repository URL, and you give a local folder. This is actually an optional thing. Otherwise, it will just create a folder that is named exactly as your project. Right, so then you go to that folder, to that either local folder that you gave or the one that was generated by the clone command. And you go to that folder, you do your work, you change some files, you write your awesome code, and now you're ready to submit the code to the server. You have to do these commands. You have to do git add and the number of files that you, like all the files that you've changed. You can also, it's just again, a Linux terminal command. It has a help. Use its help to find out options. For instance, there's an option -a that just adds all the files that have been changed. But adding them means that you kind of like put them on a shelf, and they're there. Like, this is a shelf, like, outgoing. This is the thing that you want to send out, but it's not sent out yet. You put it there, and you know that, okay, well, I've modified this file. I add it to my changes list. So it's basically treated as a changes list, this add thing. Then you want to commit. Like, commit means I commit to sending this thing over. Like, you kind of wrap it all up. Like, you take everything on a shelf, you kind of wrap it in a nice box, and now you wait for somebody to take it to the server. And this is done with push. So now you push it, you kind of like push it away, and it goes in the server, right? So there are 3 stages: the add, the commit, and the push. So adding, just prepare something. Commit, you commit to actually submitting it somewhere, and push is actually pushing it somewhere. So it's a bit confusing at the start, but once you get into it, it's very clear. There is also an insanely good guide. I can't recommend it more. This thing, so just click this link, go over it. It's really well made. It's a couple of commands with really small examples on a nice website. I definitely recommend it. It's nice to look through it. Good. You will submit the homeworks through Git. As I told you, you have to log into Git. You have to request access to a group. We will all be in one group. So once you're in, let me show that to you, I guess. So this is how the like, if you go to igg-unibonn, like GitLab igg-unibonn.de, that's what will greet you. When you get your account and password, you will be able to log in. And so what you will do is you need to go to groups, and you need to search for CPP. And you will, like, there is a lot more groups here. You will not see as many because you don't have access to all of it. But basically what you need to do is you need to find this CPP group, you need to go to it, and you will have a button somewhere, request access. So you need to click that one. Then I will get an email that somebody wants to request access to the group, and then you will be in the CPP group on the GitLab. Now, again, like I try to document everything on the slide. If something, like if you bump your head into something and it doesn't work, it's probably that I forgot some small thing, and just tell me that it's hard. It shouldn't be hard. If it's hard, tell me. Okay, and then what you need to do is you need to go to the homework repository. So we go here, of course. So the link is wrong already. I will change that. Right. So you need to go to this repository. So it's a remote repository. It's CPP Homeworks 2018. And it contains a bunch of files. So you can see them here. It has 5 homeworks, and they're all empty for now. There is just a small README inside. There is not much happening there. So you need to fork this, because you will not be able to. So there is a lot of things going on under the hood. There is all the access control and so on. You are not allowed to push into this repository, but you can create an own fork of this repository and push to that. So to do a fork, you need to click this beautiful fork button. And you click the button, you will have probably only one option, and you need to pick your username. It will fork the repository. And now this repository is your own repository. So it has the same name, but it has a different namespace. So if you don't see it now on the slide, but before it was teaching in the teaching namespace, now it's in your user namespace. So whatever your username is going to be there. And now this is your own repository. You can do whatever you want with it. You can like remove everything, you can add stuff to it, and so on. And this is the way you will be doing the homework. You will clone this repository to a local file system. You will modify files there, and you will push it to your local, to your own remote system over here. The other important part you have to do is you have to go into the settings. You have to go to members. And you have to invite a member. We have a bot. It's a homework bot, this guy. So you have to invite him to your repository with developer rights. Because this guy will actually go back to you and tell you how you did on your homework. Because you are a lot of people. I am a single person. If I would check all the homeworks by hand, it would take me probably more time than I have in a week at all. So I've implemented a system that will automatically go through your solutions and will check them and will kind of compile it in a nice table and give back to you. So if this system doesn't work, you have to tell me, because it's still not. I tested it last year. It worked pretty nicely. Hopefully this year it's more stable. If something doesn't work, tell me. I'm going to fix it. So let's do a small test here. Actually, temp is a nice folder. So what you have to do is you have to do a git clone. Then you have to pass the link. So the link is the link that I took right from here, right? So it's the same link for your own homework. You just go there and you do a git clone. This laptop doesn't have, okay. Let me change to HTTPS. So there are 2 ways of getting that, either with the SSH key or with HTTPS. Probably it's easier to use HTTPS because there you can just type in your password every time, like your login and password, and then you're fine. So let's do a git clone this thing. Now it asks for my username, and I'm Igor. It asks for my password. Okay, so now it has done its magic, and if I do an ls, there is this folder CPP Homeworks 2018. So I can go there. And let's say I want to go to homework 1. And I want to submit the first exercise. So you don't know what the homework is yet, but you will need to write like a bash script on your own, and let me just try to do it here quickly. So I want to write this script, and let's say all it does is just typing hello world. So it's just like this command will be just executed by a terminal. Right, so now I have modified the files, and I can use git status to see what is going on. So what it tells me is that, so there is a lot of boilerplate. I will not explain it now. Use that tutorial. It's going to explain it much better than I can. But the main part here is that this thing is shown in red, right? Because it's untracked. So it doesn't track the file. I need to add this file. So I add commands.sh. Of course, I forgot git. Let's try git status again, and ta-da, it's green. Green is much better than red, right? So now we have something. It says changes to be committed. To be committed, well, okay. Let's do a commit. Git commit -m is a message, and you have to have a. Why is it not wrapping? Wait. Let's try this. Git commit -m. Okay, this is weird. I can do it like this. My awesome message. The message should not be like this. Like, don't learn from me. It has to explain what you have done. So, and it kind of makes your work granular. So do a small thing, one concise small thing, add it, commit it, name it in the way what has been done. So instead of my awesome message, I would type add echo command, for instance, because that's what I actually did, right? So I do this, now git status, and now it says that there is nothing red or green, there is just your branch is ahead of origin master by one commit. Again, you will know what a branch is when you look at the tutorial, but the main part is here. I'm ahead of something by one commit. So what I can do is I can do a git push origin master. Believe me, there is master there. It's not seen on the screen. Good. So it shows a lot of things, but the main part is that it has sent something to master. So now if I go back to my repository, I go to homework 1, and I can see this commands.sh script over here. So if I open it, it shows me exactly this. So now it's on the server. And now let's see how... sure, I should have... Okay, there is like, it explains what you have to do. Of course, I forgot what you have to do. You have to specify folders for the tasks. So let's do a move command sh to task. Git at -a. So it even will show you that you didn't change the file, it just moved it, like it knows what happens. So let me just quickly move file. No. Okay. So the idea here is that now there is a folder, and what you can do here is it will actually start a build. So it will build your code on the server automatically on some server that you don't know, and this will be shown over here. So this small thing. If you click on it, you will have a lot of information. You have to click on build, and this will show you what is going on. Like you don't care about any of this text. Like you just care of this being done. The moment it's done, it will update a wiki of your project. And the wiki will look something like this. So it will be, now it's empty, but it will be a table. So this table, it will show you a homework name, task name, test name, and result. You can either pass the result or fail the test. If you have any failure, any errors in your code, the errors will also be shown in this document. So this document is updated automatically. You should never modify it. And this is your feedback loop. So you push your homework, you wait a couple of minutes, you wait till this gets updated, you look at it. This is like the errors. This is how I will evaluate your homeworks mostly. Like I will still maybe run some code. I will maybe look through some code and maybe we'll look if the style is fine, if you have some concepts that you cannot catch with automatic tools. But I tried to catch as many things automatically as I could. So let's see if this gets updated. Yeah, okay, cool. So now it has actually updated this document automatically, and it says that the homework name bash and C++ intro and the task name simple bash test 1 is failed. I didn't do it right because it was not the command that was expected, and it actually tells that, hey, there is an expected output like this, and you need to provide some, like the given input is different. Like my output is hello world, the expected output is different. So use that. The first one will be really simple. Like it's kind of like to get you accustomed to the system, so you can easily fool it. Please don't do it here, because if you in this exercise, if you just provide this, it will just work. But generally, there will be a lot of inputs, and you will not be able to just kind of adapt your code to output the thing that is needed. Okay, so that should be it. I will put all the things today on eCampus, also the virtual machines and how to use them and so on. And the homework will be, so the homework sheet will also be there on eCampus, and we're going to have homeworks for 1 week. So the submission deadline would be next Wednesday. And submission means you just upload your code to the server. That's it. You don't have to provide me any paper. You don't have to do anything. You just upload it to the server. It's all logged. I will see all the times when you do it and so on. I just need to figure out the way how to give you all access to the server. There has to be a centralized way. Okay, and I will just send you an email over the whole course of how to do it. Okay? I think I'm more or less done for today. There is the same information is duplicated here, and the last thing is the references of this lecture is. So there is an important thing that I didn't talk much about is. It's done by Bjarne Strostrup and Herb Sutter. They're like two huge guys in C++ world, and they are compiling now these CPP core guidelines. If you're unsure how to name thing, how to use thing, and so on, try to go there. It's a huge document. Use like search in your browser and search the thing you want. They will answer any of your questions generally, judging from a lot of experience, of the experience that they had throughout their career. It's very helpful. You can also read Google Code style sheets. Sometimes some things will not be really readable and really easy from the start because it kind of goes in depth, but still it's a good place to check if you're doing it right. As I told you, there's a Git guide, and if you want, you can go to C++.com and do their tutorial if you really wish to. I would probably stick with the lectures for now, but I just wanted to give you an alternative if you really don't like the way I do it. And again, there is a book, Code Complete 2, by Steve McConnell. If you are feeling that programming is what you like, this is a book that you must read in your career. And why not doing it kind of now? So, but it's a big book, so it's not mandatory for the course. But it will make you a better programmer. Okay, good. I'm done. Thank you for attention. If you have any questions, come up, ask them, so whatever, as usual. Thank you.